A common explanation for functions is that they're machines. This works for most functions. Say f of x equals x plus 2. Then you can call the function a plus 2 machine. So x goes in, adds 2, and comes out as f of x equals x plus 2. This is a good way to begin understanding functions, and most functions work like this. But functions don't always have to be so nice. Say we have a function that works on whole numbers, like 1, 2, 3, 4, 5, and so on. It's perfectly allowed to just arbitrarily pick what the value the function is. So f of 1 could be 1, then f of 2 could be 3, and then we could have this be 2, and this is 1. So there's no pattern, but this is all the same function. So what would we call this machine? You could, if you looked at the first one, it looks like it's a stay-same machine, but that doesn't work for this because 2 comes out as 3, not as 2. So either we have to limit what we call a function, or else we can think of a new way to understand functions. So a function can, instead of a machine, can be seen as a map. So these are sets of numbers. Specifically in this case, the whole numbers. Again, 1, 2, 3, 4, 5, and so on. So it's just like all the numbers in each of these. So you take any number in here and f maps it to a number in here. And we'll call that f of x. So it doesn't have to be a pattern. It can just be like this function number goes here, this number goes here, this number goes here, and so on. It's allowed. So let's consider the weird function again. So let's look at here we're going to just draw a number line instead of the blobs as before, but it's the same thing. It's sets of whole numbers. So f of 1 is 1. So that's what the map does. F of 2 is 3. So this time maps 2 to 3. F of 3 is 2. Maps 3 to 2. F of 4 is 1. Maps 4 to 1. So we no longer have to find a one-size-fits-all machine for functions, which doesn't work for functions like this. Instead, functions are now a map, which will actually fit all functions.